So, if I, for example, give you 690 degrees, is 690 degrees on Earth?
No.
Okay. So how many rotations do we need to take out to get it to Earth? One rotation. So what's 690 degrees minus one rotation? 330. 330 is the amount we need to focus on now, right? Now we get to answer the questions, right? Is what quadrant is 330 degrees in? In quadrant 4. In quadrant 4, as a quick question, what should be the sign of the cosine value? Positive, and the sign value? Negative. So now that we got 330 in quadrant 4, what is the reference angle for 330 degrees? We've done this before. Huh? What's the reference angle for 330 degrees?
60.
How did you get 60?
Wait, no, it's 30.
How did you get 30?
You look at the table.
That's not how
Or
we
you
find
can use
reference angle.
subtract. Yeah.
Yep, so we're doing 360 minus 330 degrees, which would be 30 degrees. I want you to see your work. So you want me to show that in your table. If I see numbers appear and I don't see steps, I'm just crossing it out. I'm just going to assume you borrowed it from somebody without knowing you borrowed it. Cheated. So now that I have that, I go to page 26. In quadrant 1, somebody needs to turn their phone on silent. Go to quadrant 1, and then look at 30 degrees. What is the cosine value of 30 degrees? Square root of 3 over 2. And we happen to be in quadrant 4, so we can still keep it positive, right? What is the sine value for 30 degrees? 1/2, but we're in quadrant 4, so negative 1/2. Let's look at 1440. So 1440, is that on Earth?
No.
No. Okay. So how many rotations do I need to get out to bring that on Earth?
4.
4 rotations?
So that would be 0.
So 4 rotations is 1440. So this is the same as 4 times 360 degrees, and there's nothing left over. We did stuff like this yesterday. All right? So now the angle that we need to be concerned about is 0 degrees. The angle measurement, 0 degrees. Okay. So now let's talk about quadrants. What quadrant is 0 degrees in? It's not in any quadrant, right? So for where we got quadrants, just put a dash or put none if you like writing a lot. What's the reference angle for 0 degrees? There's no reference angle, it's itself because it's not even in a quadrant, right? Now you go to page 26 again in your book of numbers. Look at 0 degrees. And tell me what's the cosine value of 0 degree? 1. What's the sine value of 0 degree? How do you find that? The second value in the order pair, right? Because it's cosine, comma, sine. First value is the cosine value. We'll learn how to read those. Questions? Okay. So you should be able to do stuff like that. Table 2. We've done table 2 before, right? If you flip your page, your notes to page, yep, page 28 actually has table 2, because we did that as a homework problem. Right? Who did that? Well, the difference now is they're adding in negative rotations. If you think about it, we said if I have a number bigger than 360, last time we were discussing heaven and hell, right? Some people say, oh, it's up in heavens and heaven is up there, and you have your weird way of explaining why heaven is up there and hell is down here. That's a whole different thing. But if I follow that, then we have to take away stuff to bring that to earth, right? We got to take away 360s, 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 360s until we get on earth. Well, if you think about the negative is on the ground now. Now it's in hell, right? How do we raise that back to life? Like that South African pastor, right? Who say you can brought back somebody dead to life. No. And people pay money for stuff. Might as well, some people got money they don't need to have, so they pay for stuff like that. So now, to dig that out of hell, you got to add 360 degrees. We're taking away 360 to bring that down. We add in 360 to bring that back up. So if I have a negative 15 degrees, in order for me to find the interpretation of that thing on earth, because in hell it's negative 15 degrees, it's learning math from Goya, now I have to come back on earth. So I got to do negative 15 plus 1/4 rotation. What would that give me? Negative 15 plus, what's 360 minus 16? 345. That's the angle measurement we have to consider. What quadrant is 345 degrees in?
4.
In quadrant 4, what does the sine value look like?
The
Sine. Sine.
Negative.
Negative. Cosine?
Positive.
Positive. Okay? Now we have 345 degrees in quadrant 4. What is the reference angle for 345? I didn't say read it from the table. It said find the reference angle. How do you find the reference angle? Thank you. So it's 360 degrees minus 345, which is 15 degrees. So now again, we'll go back and do the exact same thing we need to do, right? So, because I'm going to have a problem like that on the test, I'm going to go ahead and disrespect my own rules of not doing stuff more than 5 times, especially if we're doing it as a homework, and try to redo them.
Yes.
Because I would definitely have a problem like that on the test. So you're given that sine of 15 degrees is this thing. That's what we're given. And we need to find cosine. Those of you that took notes the last time, this is just a review. Those of you that slept through it, here is your chance. If we're given this, we know that sine of an angle is the opposite side over the hypotenuse, right? That's SOHCAHTOA, right? It's so in SOHCAHTOA. So if that is the case, this numerator is the OPP. Everybody got one.
OPP, yeah, you know me.
That. Okay? So we get to become artists in here. I'm going to call this my 15 degrees gonna call this my right angle. So then the opposite side is gonna be this way, right? This is gonna be adjacent to this angle. And my longest side is always the hypotenuse. I really don't care which one is A and which one is B, as long as I maintain that the hypotenuse is C. So we're given that the opposite side is that thing. We do not know the adjacent side. We know this side to be the denominator. I have a right angle triangle with two sides and a missing side. How do I find the missing side? Yeah, the ATT. Plus B squared, we don't know, is equals to C squared. You know you didn't take note the first time. This is your chance to take the note. You did not take note the first time. So now, what does the square do to the square root? Cancels it out, right? There is one square, so we can only cancel one square root. Again, we're back to that whole Super America plus donut situation. So this is 2 minus the root of 3. That's just the A side of that donut that comes out every time you bite it. Juvenile diabetes. Plus x squared. What's 2 squared? Again, please learn the process, not the exact piece. So, again, this process, because there are folks who are just going to memorize this, and then when I put a 5 in here, or put a 3 in here, they're going to be like, oh, we didn't do that, because they memorized when there were 2 in here. So it's the process. So minus 2 to get rid of that. I'm going to walk away from that one. So, plus the root of 3. That's strange things. So these two are going, right?
Yeah.
I got x squared is equals to 2 plus whatever this thing happened to be. Right, because I'm not looking for x squared. I'm looking for x. Okay? Eyes out. That's how we sleep now, man. We pretend like we're writing. Come up with something new, man. I'm saying that. John can't attest to that. Yeah, right. We've done that before. Not like you're writing? Yeah. Okay. So now we just found x. So x is our adjacent side, which is this thing. Now we have a triangle with all 3 sides known. Right? Now I can find cosine, sine, and tangent. Right? Because SOHCAHTOA gives me the relationship between opposite, adjacent, and hypotenuse. So, the first problem we have on the board is 525. So, it's 525 on Earth. Nope. So, 525 is not on Earth. How do we bring it down to Earth? take out a rotation, right? All right, so what's 525 minus 360? 165? Okay, 165. So that's the angle we have to consider. What quadrant would that be?
2.
All right, quadrant 2. In quadrant 2, the cosine is
Negative.
negative, and the sine is
Positive.
positive. Okay? What's our reference angle for 165 degrees? How did we get that?
180 minus
180 minus 15. So reference angle is 180 minus 15 minus 165, which is 15 degrees. What'd you get? Oh, 180. Is that what we reference angle? According to SOHCAHTOA, what's cosine?
Oh,
C-A-H. Adjacent over hypotenuse. So we need to find the cosine of 15 degrees, which is the adjacent side over the hypotenuse of that right triangle. Did we just find adjacent? Yes, we did. This piece right here. And what's our hypotenuse?
2.
That's cosine. But we're in quadrant 2, so cosine should be. And if you remember from the last time we did page 28, we said all we're doing now is we copy and paste everything, except now we're just changing the sign from positive, negative, negative, positive, based on what quadrant we're in. You see that? So on the 7:05, looks like a time you set for your alarm, 7:05. So for 7:05, which is the next problem now, those of you who didn't get it the first time, here it comes again. For 705 degrees, is that on Earth?
No.
No. How do we bring it down to Earth? Take out one rotation. So what's 705 less one rotation? 345?
Yes.
All right. Now 345 is the angle we get to talk about. Right? When this thing was high up there in the heavens, it was 705. When it came down to Earth, we called it 345. Now 345, what quadrant is that?
4.
Quadrant 4. In quadrant 4, the cosine is, and the sine is negative. Right? So we need to find the reference angle of 345 because we don't know what the cosine of 345 is. Right? So we need to find a reference angle. What's the reference angle for 345?
15.
How did we get that?
360 minus 345.
Yeah, 360 minus 345. 15 degrees. Do we know the cosine value for 15 degrees?
Yeah.
Yeah, we just found it, right? But we're in quadrant 4, so it should be positive. Do we know the sine of 15 degrees? Yes, it's given to us. But we're in quadrant 4, so it should be. There you go. Questions? Because you will be expected to fill in the table like that. To do all of these things, give it something, draw a triangle, find the missing side, and then just do your thing. Okay, so here's the other thing I expect you to be able to do. Hello, pay attention. Is I give you a sine value or a cosine value and say, can you represent that? So for example, go back to your first set of homework we did, and that will be on page 28. Make sure you're able to answer questions like 3, 4, 5. Those were homework questions we gave you. Page 28. Problem 3, 4, and 5. We had those as homework questions. There will be similar problems like that. So you were given, for example, that your cosine, the sine of an angle is 1 over the root of 3. You're given this time that we don't know the angle, so magical angle theta is 1 over the root of 3. If I'm given sine, so SOHCAHTOA, that's the so in SOHCAHTOA. If I'm given sine, what information am I given by this triangle right away? I'm given the opposite and the hypotenuse, because from SOH, that's what we get. So the top number is everybody's property or other people's property. And then this is the hypotenuse, because we're talking about sine. If this was cosine, then I have the adjacent. That's the cut in SOHCAHTOA. And the hypotenuse. Okay? So I get to come here and say, well, this is the opposite side, so that's 1. This is the hypotenuse, so that's the root of 3. I do not know this. See that? And then we get to go back through here again, do the whole, the square on A plus the square on B has to be equal to the square on C. Everybody see that? So we go back. So if you were given the sine, and you've been asked to find a cosine, make sure you can first find the adjacent. If you're given the cosine, and you're told to find the sine, that means I give you the adjacent and the hypotenuse. I need you to find the opposite. We're good? There was actually a problem in the work. Let me ask you that, and see if people can extend this knowledge. What if I give you that cosine of some magical angle is that? And I still find the sine of that angle. What information am I giving here about this triangle already? I'm giving adjacent over hypotenuse, right? Because it's the CAH in SOHCAHTOA. So what's the adjacent? 1. Okay, what's the hypotenuse? How'd you get that? Yeah, he wrote this as a fraction. Because that's 1.5 is. And then this becomes your adjacent, and this becomes your hypotenuse. See that? Now we're going to find opposite using a squared plus b squared is equal to c squared. Are we good? Let me ask you a question. Because, Goya likes to extend stuff. What if I gave you this? I gave you that the cosine of some angle is the square root of 5 over 2, and I said find the sine of that angle. Do what? All right, you're given the adjacent and the hypotenuse, so what's the adjacent here? The square root of 5, okay? And the hypotenuse? 2, and we need to find the opposite? Okay, she said a squared plus b squared is equal to c squared, okay? Now what? What are we plugging in for what? Okay, so stop me if you can. Right? What's next? So, Super America, donut stuff again. What's 2 squared? Okay? Stop me if you can. What else? Nope. Do what? Subtract 5? Okay. Subtract 5. Somebody said, wait. What?
It would be a negative
It would be a negative
one.
1. And then we can do what? We can't have a square number equals to a negative. Why not? Because no real number times itself gives me negative, right? Or if we take the square root of both sides, we learned this from last semester, those of you who had me. What's the square root of negative 1? I. If you love it, you should put an I on it. Or remember that whole thing? We had a square root of 4 was 2. Square root of negative 4 was 2i. Square root of 9 was 3. Square root of negative 9 was 3i. Right? If you love it, you should put an I on it. We're good? But, so, can we draw a line with a measurement of I? No. So anybody wants to tell me why I kept saying, stop me if you can? Square root of 5 is bigger than 2. We have a side that is longer than the hypotenuse. Does that make sense? No, because the hypotenuse is supposed to be the longest side, right? So you see, we wasted all this time. Global warming. Well, the denominator should not be smaller. We're dealing with a sine or cosine, because the denominator is our hypotenuse. It should always be bigger. So go ahead and give me this. I'm going to just write side, not possible. This would not be a right triangle because the hypotenuse is shorter. But you could do all of this and still give me the same thing. Therefore, not possible. It's just too much. Right? This is doing the most. Just like Goya, like I said, I do the most every time. Because I do the least. See? We're complementing. So I do nothing, I do everything. Okay, question. What's your question? So, let's do this. I give you 600 degrees. Real quick, everybody, test your skills. 600 degrees. Have I got that? 600 degrees. Here's the first question. What is the quadrant? Can we determine the quadrant right away by looking at 600 degrees? How? What is the first question you should always ask yourself if I give you an angle measurement? Is it on Earth? Are we talking about a Martian? Did somebody come here in a UFO? Right? So it's not on Earth because it's 600 degrees. So how do we bring it down to Earth? Minus 360, right? Okay, all right, that's good. So what's 600 minus 360? 240. So that's the angle that's on Earth now, right? That's the measurement. So when you were up there, you were 600. Now we brought you down here. Now you're 240, right? When you were with your crew, you were talking smack. Now you're here by yourself. Right now you're 240. Right? So what quadrant is 240 degrees in? Quadrant 3? In quadrant 3, what is the sign of the cosine value? Negative. And the sign of the sine value? Negative. So they're both negatives in quadrant 3, right? So 240. What is the reference angle for 240? 60 degrees?
Yeah.
So then go to page 26 in your book of numbers. What is the cosine of 60 degrees? 1/2, but it's in the third quadrant, so it is negative 1/2. What is the sine value of 60 degrees? Square root of 3/2 is in the third quadrant. It should also be. If you can do those things, man, you'll go to tomorrow. We're good now?
What is the homework?
So here is what I will ask you to do for your homework. For your homework, page 28. Go back, look at page 28. Be able to do stuff like table 2, actually page 27. Be able to do stuff like table 1, and then on page 28, table 2, And pay attention, particular attention to problems number 3, 4, 5. There will be problems like that. Okay? You will have 99 problems like that, and the math will definitely be one. So tomorrow, your test is not going to be, everybody's not going to take the same test, so don't cheat on people. Some people are going to have a different test. I was going to look at people who said smack about my university. For those people, I'm going to challenge them on a math level. So
you have to do the math level. You know you can't do it. That's all.
It's easy for you to say, okay? I have a bad temper.
we still better than National American University though, because I heard you guys accepted there. One nice song, nice chance. So, MLG, bye bye.